Alright, so the other two common angle measures in the first quadrant are 30 degrees, or pi over 6, and 60 degrees, or pi over 3. Now, like I said, we're not going to use the time to go through and explain why, but I'm going to show you the points to use. If we can just associate these points with 30 degrees, or pi over 6, and 60 degrees, or pi over 3, then we can figure out the 6 trig values evaluated at these angle measures. So for 30 degrees, or pi over 6, we use the point square root of 3 over 2, 1/2. And for 60 degrees, or pi over 3, we use 1/2 square root of 3 over 2. So you can see it's very easy to get those mixed up. I really don't know an easy way to remember that unless you can just remember, say, one value for one of them. Like, if I can remember that the sine of pi over 6 is equal to 1/2, and that's the same thing as the sine of 30 degrees, if I can remember that one value, then I can remember that sine goes with y, and I should write that in the y position of the ordered pair. That's how I personally learn how to remember all of the values for pi over 6 and pi over 3. I just made myself remember that the sine of pi over 6 is 1/2. So then I can write down the 2 points. I can put a 1/2 in that second position for 30 degrees, or pi over 6, and then I can fill in the other 4 because, of course, you got to remember square root of 3 over 2. So you put that there, and then the other point you just switch them. Okay, and then from that we can get all 6 values at each one of these angle measures. With the cosine of pi over 6, that's going to be the x coordinate, so it's square root of 3 over 2. The tangent of pi over 6, that's y divided by x. So 1/2 divided by square root of 3 over 2. And then we need to flip and multiply. So this is 1 over the square root of 3, or the square root of 3 over 3. Okay. Cosecant of 30 degrees, or pi over 6, that's going to be 1 divided by the y coordinate. So 1 divided by 1/2. Flip and multiply, and you get a 2. The secant of pi over 6 is 1 divided by the x coordinate. And the x coordinate is square root of 3 over 2. So flip and multiply, you get 2 over the square root of 3, rationalize, that's 2 square roots of 3 over 3. And then the cotangent of pi over 6 for 30 degrees, that's going to be the x coordinate over the y coordinate. So flip and multiply, and that leaves you with just square root of 3. Alright, we can do the same thing for the sine of 60 degrees, or pi over 6, the cosine of 60 degrees, or, I said pi over 6, I meant pi over 3, or pi over 3, the tangent of pi over 3, cosecant of pi over 3, secant of pi over secant of pi over 3, and cotangent of pi over 3. You could, if you like to recognize patterns and use patterns, if you ever write down all of these, then the sine and the cosine are just changed. the tangent and the cotangent are just changed with each other, and same with cosecant and secant, they're just changed. But I'm going to go through them real quick. So if we have this point for 60 degrees or pi over 3, we have the point 1/2 square root of 3 over 2. The y coordinate, square root of 3 over 2. Cosine's the x coordinate, that's 1/2. Tangent is sine divided by cosine, well, or y divided by x. So that's square root of 3 over 2 divided by 1/2. Flip and multiply, and you get the square root of 3. Notice that is the same thing as the cotangent of pi over 6. It's just flipped. It's just the opposite. Alright, cosecant of pi over 3. Cosecant is 1 over y. So 1 over square root of 3 over 2. Flip and multiply. So you get 2 over the square root of 3. Or 2 square roots of 3 over 3. The secant of pi over 3, that's going to be 1 over x, so 1 over 1/2. Flip and multiply, you get 2. And then cotangent of pi over 3, or 60 degrees, is going to be x over y. So 1/2 over square root of 3 over 2. Flip and multiply. The 2's cancel out. And you have 1 over the square root of 3. Rationalize. And you get square root of 3 over 3.